To continue with the discussion of the cases for beam section, this is the third and the last case, that is over reinforced section. We have already discussed something called as balanced section, which is, as I mentioned, is the ideal case. Second one is under reinforced section. So from the name you know that the steel that is provided is lesser than that you get actually for a balanced section, that is of the value PC. Now from the name here again you can make out this is a over reinforced section. So for under reinforced section, value of P was less than PC. For over reinforced section, value of P will be more than PC. More than that is required. That's the reason it is called as a over reinforced. More reinforcement. Reinforcement is steel. So over reinforced section. Now in this section, reinforcement provided is more than the critical one, that is value PC. So this particular figure shows a over reinforced section. Now if stress in steel is permitted to be equal to maximum permissible value T equal to sigma St. So now what we will do, consider that steel is allowed to reach its maximum value sigma St. So in the stress diagram from here, if it reaches sigma St, that is BE1, which is equal to BE1, the corresponding value of stress in concrete will be AD1. So corresponding stress in concrete will be equal to some value C1, which will be equal to AD1. Okay. Now again from figure we know that C1 is greater than C. Okay, here we can make out that this C1 is greater than the value C, where C is sigma CBC. So now again, this is not possible. Okay, you cannot have a more value of stress in concrete than sigma CBC. That is the permissible stress. So if it goes beyond that, it is going to fail. It is going to rupture. So we cannot allow this to happen. So the tensile stress, therefore, the tensile stress of a value T1, which is equal to BE, is allowed. Again, see the figure here. So some value of tensile stress T1 of EB is allowed. Now if this is done, then the corresponding compressive stress in concrete will be equal to C, which is equal to AD. Again, just see the figure. If T1 is applied, okay, or if T1 is allowed, that is BE, then the corresponding stress in concrete will be equal to C, that is A times D. Thus, in an over reinforced section, steel reinforcement is not fully stressed to its permissible value, but concrete is stressed till sigma CBC. Okay. Now in this case, the moment of resistance is determined on the basis of compressive force. As in under reinforced section, it was determined by the tensile force. Here it is determined by compressive force. So MR, moment of resistance, will be equal to C into lever arm. Okay. As concrete is fully stressed, we consider the compressive force. In the previous case, in under reinforced section, as steel had reached its permissible value sigma St, we had considered the tensile force. So we already derived what is capital C, which is half into KD into B into C into lever arm is J into D. Okay, so this can be written as half. C will be sigma CBC as concrete will reach its permissible value. So value of C will be sigma CBC. So this will be equal to C J into K into BD square. So it is half sigma CBC into J into K BD square. So this is the equation to calculate the moment of resistance for an over reinforced section. So just to briefly discuss the three sections as three cases again. Okay, here balanced section, under reinforced section, and over reinforced section. Okay. As I said, balanced section is the ideal condition. With N will be equal to NC, P will be PC, here K will be KC. So all the critical, where P is given by 50 into KC upon RC. In under reinforced section, value of P is less than PC. This is the first condition. The reinforcement that is provided is lesser than what you actually get for balanced section. And over reinforced section, it is P is greater than PC. Now due to these two, we have already discussed what happens in the section with the stresses. So here sigma ST or the steel is reached its permissible value, but concrete will be somewhere at C1 which is less than C. So concrete does not get fully stressed, but steel fully gets stressed here in under reinforced section. Also here, due to this, the actual neutral axis is above the critical neutral axis. So N is less than NC. Here, due to this condition, what happens is sigma CBC is fully attained and steel is reached some value T1 by M. That means steel is not fully stressed, but concrete has reached its permissible value. Here T1 again is less than value T. Here if you compare the depth of neutral axis, NC is greater than N. Okay, I think I missed to discuss about this, so I'll just go back to the diagram and do it. So if you refer to the diagram here, just see this. What is the condition for NC critical neutral axis? It is C corresponding to T, that is sigma CBC corresponding to sigma ST. Now where is sigma CBC? We'll just locate the point. This is the point D, and where is sigma ST? This is the point E1. So if we join these two points, okay, this is the point where the stress is 0. And the neutral axis corresponding to this particular point is critical neutral axis. So here value of NC is less than N. So here NC is less than N. Okay. So we have already discussed three cases of design, that is balanced section, under reinforced section and over reinforced section. It's a small assignment. I want you all to find out which section is the best for design. A balanced section, under reinforced or over reinforced. Just think and let me know. I will ask in a live class. Thank you.